Yeah, we're here again. This is Momentum Minds Efforts. Today we'll be discussing physics. This topic, most students find it difficult and nothing to deal with, yet it is extremely simple. The topic is position, distance, and displacement. Now, why is this topic difficult for students to comprehend? I'll first of all discuss the position aspect of it. For example, I'm here. Maybe my brother in Kaduna called me that, where are you? And I said, I am here. You'll be wondering, where is here that I'm talking about? That doesn't make sense at all. So, in describing your position in physics, you must have what we call a frame of reference. A frame of reference, or origin, or observation post. All these are the same thing. So we're going to explain what is the meaning of this in describing wherever you are. Without this frame of reference, description of your position would be very ambiguous. People will not understand what you are saying. Let me now put something in to drive this home clearly. Assuming we have a house, a school around there. Let's call it school. In front of the school, here, Paul is standing here. Paul. There's a road like this, major road. Opposite the school at the other end, this is Joe is standing here. Now, as they were standing, a car moves in this direction. If they ask Paul, the car that has just moved, where is its direction? Paul will say, the car just moved from my right to my left, and Paul will be correct because of where he's standing, where he's observing from. But if they ask Joe the same question at the other end of the road, Joe will tell you that the car moved from left to right, then which of them is correct? Paul says the car right to left, while Joe says the same car left to right. And despite the car is moving one direction, they have described the direction of this car differently, two contradictory observations, because they failed to put the frame of reference. What's the frame of reference in this regard? If Paul had said standing in front of the school, the car moves from my right to my left. Yes, this would be correct because he had put the observation post where it's taking the measurement from, and that's the frame of reference. But Joe, if Joe had said standing opposite the school, on the other side of the road, the car moves from my left to my right. This time, Joe is correct because he has clearly indicated where he's measuring from. That is his frame of reference. So, without a frame of reference, you cannot describe your position accurately. Let me give you another example. You are at the train station, you are standing here. A friend of yours is standing at the other side, and a train moves in between you. There's a guy sitting inside the train as it's moving. You will say the guy just moved from your left to your right. Then your friend at the other end will say the guy just moved from the right to the left. Meanwhile, the guy you're talking about is in the train. He will tell you that he is not moving. For a single person, there are three different descriptions. If the guy at the other end said, at the front of the platform, the train moves from left to right, the other end said, at the back of the platform, the guy is moving from my right to my left, then the guy in the train says, sitting inside the train. So in describing your position, it is always good to have a frame of reference or your observation post where you are measuring from. Otherwise, you'll be given contradictory directions. Thank you. Now let us look at the other side. This is distance and displacement. This one too is a little bit confusing to students. Then how is it confusing? That is what Mentor Mind FS wants to bring to your notice here. Now, if you ask any student that what is the difference between distance and displacement, it will tell you that distance is a scalar quantity while displacement is a vector quantity. Student is correct. But that will not teach any student the foundation or the basis of the two events. Let's say this is distance and this is displacement. Displacement. Now, distance, the difference between them, this one is a scalar quantity, while displacement is a vector quantity. Of course, any student knows this. But the other one I want to have is what I want to emphasize on, because it's one that brings the real knowledge of the distance to the forefront. 2. Distance is path dependent. Path dependent. Dependent, while displacement is path independent. It is this second one that is not clear to most students, and the second one we want to lay emphasis on today. What do we call path dependent and path independent? For example, somebody is moving from point A to point B. Rather than moving straight, decide to walk like this, and go like this. If you want to measure the distance is path dependent. You have to calculate all the distance covered by the person reaching this position, B on B. But in case of displacement is path independent. It's not concerned where the route you took to where you are. It's concerned with where did you start the journey at point A, where does it end at point B. This is where I'm going to measure. To make it clearer, let us say this is a house and it belongs to Janet. 400 meters away from home. Janet's church is here. This is Janet's church, which is 400 meters from home. Let's call this a church. One Sunday, the distance itself is 400 meters. One Sunday, Janet left home for church. She got to the church and discovered that she had forgotten her Bible at home. She now came back home. By the time she got back home, what is her distance? What is the distance covered? Distance covered. And what is her displacement? What is her displacement? For distance covered, Janet moved 400 meters to the church and 400 meters back home. So total distance covered by Janet, total distance is possible. The 400 meters from home to church plus the 400 meters from church back home, and that's the total of 800 meters. That's simple and clear enough. But is the displacement the same thing? No. Now let us see the difference between. Let us now see the displacement of Janet. Where did he start the journey? At home. By the time he's measuring, taking his measurement, where was Janet? At home. As far as this is concerned, displacement, Janet is still at home. So the displacement is 0 meters. Now, let me explain this in terms of vectors. Now, when it's going home, the displacement now, displacement is equal to 400 from home to church plus another 400 meters back home. But because they have different directions, you put minus here to show the direction of the two are not the same. So that will be 400 plus minus 400. Of course, in mathematics, when you have minus and plus positive sign, the plus will give way to the minus. 400 minus 400 will give you 0 meters. So, because displacement is independent of the path taken by Janet, what is concerned is where did it start the journey? By the time you do the measurement, where did it stop the journey? So, for displacement, it started the journey here, and when it now came back, it want to measure the displacement, she's still at home. So for displacement, it is 0 meters. But for distance, yes, it's not, it depends on the path. We have to measure all the path taken by Janet in getting to a road. I think at the momentum mind efforts, we have shown you something again. The distance, the difference between distance and displacement, which I think will help you further and broaden your knowledge about the difference between distance and displacement. Thank you. See you next time. Bye-bye.